So lately I'm looking at Galois theory, and multiple concerns instantly come to mind as soon as I understand what the fuck is going on here. Right? Not that I was completely unaware of it before, but Jesus Christ. One, this one was always obvious. If it's allegedly so pivotally important, why doesn't it have an actual fucking name? It's called Galois theory because of the work done on it by Évariste Galois. If it's actually important, then you can name it for what it does, not who made it up. This is a chronic problem in science and math. You just name shit after a person. Even when they're never the only person that worked on it. They're never the first person who worked on it. They're never the last person who worked on it. What the fuck are you doing? Two, it's the tool which convinced everyone that polynomials over degree 4 don't have generalized solutions. The problem here is that's not what Galois theory tells you. Galois theory speaks on whether polynomials have generalized solutions composed of the operations addition, subtraction, multiplication, division, and taking radicals. That's it. That's the way that it's used. There are many other operations available, and there's absolutely no rule against developing more in the future. So that could potentially include something that might yield generalized solutions to a quintic or something. This isn't to say that it's not useful to understand that you can't have a generalized form of solution for a quintic using radicals. That is absolutely a nice thing to know. But the significance of this discovery is almost universally overstated. Even people who will talk about it and say, yeah, this is what Galois theory really said. It only speaks on you can't do this with radicals. They will immediately turn around and say, yeah, it means you can't do it. No. What the hell is wrong with you? Why do mathematicians have absolutely no idea how words work? What the fuck? You claim to be rigorous, and yet you casually say stupid wrong shit all the fucking time. No. Galois theory doesn't prove that you cannot have a generalized solution for a quintic. What it proves, sort of, the whole concept of mathematical proofs I have issues with. But sure, we'll just, assuming that that's even any good, what the Galois theory demonstrates is that you cannot do it with radicals. Okay. Now this ties into 3. As with pretty much everything in math that I've looked at, it's chronically described wrong and incoherently. So things it allegedly proves are not rigorously demonstrated, and they're just claimed for the most part. How it behaves is not explained, just asserted, right? So why does it matter that you have a prime number? Why is that the thing? Why is it with the quintic, you go to 60, whatever you want to call them, and that's because 60 is not prime. That's why. Why is that? Why? Given how poorly prime numbers are understood, I don't trust that the underlying logic to that even makes sense. I don't fully understand it. I've glanced at it and like, maybe this is okay. But it's really hard to find somebody who doesn't just hand wave and say, yeah, it's been solved. It's because it's not a prime. It's because 60 is not a prime number. That's why you can't solve the quintic. That doesn't sound right. That's not an explanation. All right. And now, something worth noting, and is that work with infinite series increased significantly in the wake of the publication of Galois theory. Right. They were already popular. Right. Infinite series were already popular because analysis uses them all over the goddamn place. But there's definitely an uptick after you get the publication of Galois theory in the use of infinite series. And I think what happened here is it effectively convinced everyone to give up on doing things in certain ways, right? So dealing with infinite series, while awkward and it sucks, is now sort of the best available tool, right? But it should be noted that the use of infinite series in this way is really just an outright admission that you're using the wrong tools. Right? So instead of embracing this act of using them, what people should have done, along with using them, go ahead, develop them. It's not a bad thing to develop, improve the ways to work with infinite series, of course. But alongside that, seek alternatives. Seek alternatives. Galois theory says radicals aren't sufficient for working with quintics. Infinite series suck, but they can get us good, reasonable, practical answers, solutions to problems. Potentially quickly if you mechanize it. Note the time frame. Hey, look what happened. Yeah, there's reasons that that's what happened at this point in history. It's not like a magical white man figured out everything. What it is we broke math in certain ways. Yeah. And even, early 1900s, right? You have Srinivasa Ramanujan. What is he so good at? What is he so amazingly good at? Infinite series! And he did almost nothing other than work with infinite series. And that means that he never really produced exact solutions to almost anything. But that was absolutely amazing to the mathematical community. The mathematical community ate that shit up. Like, here's your approximate solutions to everything, guys, that are nicer than the ones that you've been working with in certain ways because there's fewer terms, even though the terms are more gnarly, so it's really the same complexity. Mathematicians ate that shit up. Why? Why is that where the culture was at that point? Right? So now, for instance, right, we can consider, like, the problems with infinite series, right? So we've sort of gone off a tangent here. That's fine. So in analysis in general, and taking limits in particular, right, this hinges on the notion of evaluating an expression, not at the value that we can express normally, but at the closest possible value to it on one side or the other. Maybe both, right? Depending if it's continuous, discontinuous, whatever's going on, right? So if you want to find out what 1 divided by 0 is, you can't evaluate 1 divided by 0 directly, because despite the claim that 0 is an integer and rational numbers are integers divided by each other, you cannot divide by 0, right? This gives me problems with the concept of integers. Anyway, but we can evaluate if we just move off of 0. So 1 divided by the quantity 0 plus k, or just 1 over k, where k is any positive value, we're fine. Now we're taking the right-hand limit of 1 on 0. It's the way we normally speak of it. But there's a mass hysteria mindset that took hold, and it says that k will be infinitely small, but more than that, it will have a cardinality as defined by Georg Cantor, and as such, it will probably have a cardinality of something like Aleph naught. Right, now, this is a problem because there's There's all these different cardinalities of infinities, right? This is the simplest, most basic, which means there's a lot of shit between k and 0 if we define it this way. If we're in this mindset that this is how infinities work, and this is how we do this, we walked ourselves into a trap. Okay? So now, this now means that k is part of a monad, which simply means that it exists within a regime of values that cannot be reached via arithmetic means from either 0 or 1, right? And it also means that we're still so far away from 0 that 0 cannot be reached from k via arithmetic means, right? So what we've tried to do is get as close as possible to 0, but we're still infinitely far from 0. Because what we're doing is we're using arithmetic. And the inability of arithmetic to bridge the gaps between values in this way is what the mathematical term infinite almost always refers to. But it's actually possible to be far less stupid than this, right? What if we just define k to be the successor to 0? Now, sure, you can't reach it arithmetically from, say, 1 or 13/90ths or whatever the fuck. But you fucking couldn't do that anyway. So that's not a loss, right? And there's no esoteric philosophical baggage bullshit that comes along with it, right? Except history. The current foundation of mathematics operates on an axiom, an axiomatic framework that includes the successor function, which defines 1 to be the successor to 0, which doesn't make any goddamn fucking sense. It breaks math. It breaks all kinds of shit. It is the ultimate source of all of the problems which introduce incompleteness. This is demonstrated if you fucking read Principia Mathematica, and alongside that, I don't recall the title because it was annoying. Kurt Gödel's work where he introduced the incompleteness theorems. If you actually read them and understand what the fuck is happening, what happened is accepting Peano's axioms, which includes the successor function, which defines 1 to be the successor of 0, broke everything. This is why, a few years prior to the publication by Gödel of the incompleteness theorems, you have Moshe Pressburger producing Pressburger arithmetic. It's limited, it's reduced, because when you do it that way, you avoid noticing the incompleteness. You don't actually avoid the incompleteness, you just avoid noticing it, because your mathematical toolset is now too pathetically weak to actually do enough to find it, to run into the problem. Okay? So what we have here probably is this philosophical problem. We're like, well, 1 is the successor to 0, so the only way to get from 1 to 0 is by using these tools like division and exponents and shit like that. No. If your number line is goddamn continuous, right? If your number space, whatever, your field, whatever the fuck stupid name you want to call it, if it's continuous, then there has to be something right next to 0. There has to be something absolutely adjacent to 0. It's the only way you can get away from 0 is to be able to move from it. So there has to be something that's right next to it, by definition. In one move, we can get there. Using arithmetic, coming at it from the other direction, you can never get there. This is true. This is what Cantor's work with infinities and all that bullshit is demonstrating. That arithmetic is the wrong tool to do this with. Right? And that's the point with Galois theory. Like, it is telling us that you cannot find a general solution to a quintic using radicals. But so what? That doesn't necessarily mean anything. And then everybody obsesses about it and they're just like, oh, it's impossible to do it. You don't know that. Maybe it is. Maybe it is. But this is not a sufficient demonstration to actually rule out the possibility of having a general solution to a quintic. It just gives you can't do it with arithmetic, right? The tools of arithmetic can't do it. Because if you can't do it with radicals, you can't do it with higher order operations in arithmetic, and you can't do it with lower order operations in arithmetic. So arithmetic is the wrong tool to find a general solution to a quintic. This is true. This I accept. Well, this might be true. But I accept that, and I might be wrong in that. I might be, herd mentality bullshit going on. I doubt that. But, yeah, that's what Galois theory is actually telling us. It's not telling us that you can't do it. It's telling us that you can't do it with arithmetic. Okay? But we already know arithmetic has problems. This has been well established. Right? This is very similar to trying to double the cube using a ruler or a straight edge and a compass and a straight edge, right? So you got like a slab of stone, a compass and a straight edge. You can't do it. Well, no. You can't do it in a finite number of steps, right? You end up with an infinite fucking series. You can approximate it arbitrarily well with infinite steps. Okay, with a ruler and with a compass and straight edge. I don't know why I keep saying it wrong. With a compass and straight edge, you can approximate doubling a cube to any degree of precision if you're willing to accept that your process is an infinite series. Okay, but if you just give me a sheet of paper and absolutely nothing else, I can do it in like 4 seconds in just a few moves. If it's a square sheet of paper that you handed me, I can do it in literally 3 moves. This is the point. We're using the wrong tools. You're obsessing over using the wrong tools. Why? It's demonstrated that your tools are wrong. Stop using those tools. Look for a different tool set. This is what Galois theory should tell you. But apparently nobody is seeing it this way. I don't understand. I don't understand this claim that mathematics is like rigorous and like stuff is well defined and shit. No, it fucking isn't. What are you talking about?